it froze this whole time.
Like since the bottom?
Yeah, because we started running.
There's so many businesses here. Holy.
I need a pee, dog. Oh no, we're back. We're back now.
Yo, did you guys see that?
Well, hey, did y'all see that or no?
Wait, why am I interested? I'm interested in somebody else.
Yeah, they switched it.
Oh.
It lagged. Hey, did y'all see that or no?
Oh my god, there's a dog.
Y'all didn't get to see any of the ride up? Fuck, we gotta go back down. I'm using the restroom.
How do we get them back down?
That was lit, right?
That was fun. I took a little video. I was literally holding on for my life.
Damn, bro. Chat.
Hello? Hello. Okay, so this is the second time I'm going to stream, and I'm going to work on the same project that I worked on yesterday. We are taking it easy a little bit. So yesterday we thought about the general idea. What's the concept in general and how does it work? And we described it in a repository on GitHub, and we called it fire hose. And we streamed for like 3 hours yesterday. We talked about how this should work, the goals and everything. So let me post it here. And we are in the first writing about the project. What we are trying to do is just to get a clear idea of what the project will be doing and write it in a way that if you are the first time to follow the stream on Twitch, you kind of get what's going on. It kind of onboards you on where we are right now. So this is what we are doing. This is what we are doing. Today I started late a little bit because I finished the work a little late. We had some team event. It was pretty nice. And yeah, okay. Also today I made a change. I realized the license works both ways. So I choose yesterday the GPL license, and that means that you can't use this project in any commercial stuff. But let's say that this project, I really like it, and it became like a nice framework that I would like to build another project on, like a game or something that I would like to sell. I need the license to still allow me to do that. So this is why I changed the license to MIT license instead of GPL, which GPL was a bit restrictive with commercial stuff. So yeah, so that's one of the changes that I did out of the stream. And what we are trying to do now is to continue to write about the project, and we will start to write some examples or like public interface that we expect if you are a developer and you want to use this project to build your game, to build your web service, to build your consumer, like whatever project you are building, you should be using this public interface. This is how it should look for you as a developer when you are using this project as a dependency. Yeah, so you can think of this project like a framework. Yeah. I think the project is called Golang CI lint. Golang CI lint. Yeah, so this is a project that gives you all the linters that Go has. It kind of aggregate all the linters and you can configure it in one place. It's pretty cool. We use it all the time. Anyway, non-functional goals. So 0 heap allocation as much as we can. Maximum Golang CI lint configuration. Minimum dependencies. And minimum exported interfaces. Right. So how... So use case. What are the use cases? Game engine. Oh, okay. The easiest one first is web service that reacts to HTTP calls and do several actions like a CRUD, like create, read, update, delete operations. Yeah, that could be a pattern that you can use it for a web service. You can use it also as a Kafka consumer producer. for multiple consumer groups and topics. Yeah, so you can like present your or like convert all your logic into these rules where you say, okay, we are consuming from this topic with this consumer group ID, and we are producing here or writing to this database or writing to this queue. So this is so groups, topics, yeah. It could be also like a SQS queue processor, ETL processor. Yeah, so ETL is what was it? Something transfer load. What was ETL stands for? ETL, extract transform load. Yeah. So you get the data from somewhere, you transform it, and then you put it in a target system. You can consider it an ETL. SQ ETL processor. Or an ETL processor in general, from SQS to DB to Redis to whatever. Game engine. Your source could be keyboard, mouse, and your effects could be movement for for some creatures or creating a pollet or something. So all of these could be rules. So it depends on how fast we are going to get this system. This is the a challenge that we are trying to solve here. It's really not that easy for games specifically because it has a really tight loop, and anything that you waste time in it in the middle, it's gonna make you lose. You die. Yeah. So you allocate memory, you die. That easy. Yeah. So these are use cases. So how to use? This is the public interface we are trying to. Now here we are trying to tell the user how you are going to use this project. If you are going to write a set of rules that's going to listen on some source and do some kind of a change in the system, how would that work? So we can think of it this way. So we can import. So first you need to, this is Go. So you import the project. Import it. And in your function, you need to, oh, wait, I have something that I wrote yesterday here. Here it is. Right. Yeah. Twitch message. And there was here rules. Yeah. So you define the rule and you are getting the message from somewhere, applying some condition, and then there is a cache maybe, then to, yeah, looks great. Maybe we can just make it a little bit, doesn't have to have a cache for now, just make it simple and direct. So yeah, you are defining a rule and then you create a context, you add a rule here and you start. Yeah. There's also a way where you can listen to an interrupt, and this interrupt, when it happens, it's going to cancel the context. So yeah, when this context is cancelled, the fire hoses should also like stop this start function. Like this is a blocking function. So this is the basic idea. What also we're trying to do, also non-functional goals, is rules are data, not code. So that means you are not allowed to call a function. You are not allowed to have an address of something. You're not allowed to set like a function in there. You can't point to a function or point to a method. It should be just data. So you can serialize it to JSON or YAML and deserialize it from JSON and YAML and so on. Yeah. So this is the reason I didn't use hey sources.twitch chat message. I didn't use sources.new twitch chat message. No, it's not a function call. You initialize the thing directly in the place. You know, you don't have indirection. You know, we are going to avoid having indirections as much as we can, and the function call is an indirection. So yeah, they are data structures. And when you do that, that means the compiler will know the size of this variable. So it can allocate it on the stack, which is what we want. We want the compiler to know the size of things and not to have pointers as much as we can. And actually, we should avoid interfaces, but this is probably not avoidable, but we will try. And the compiler should just know the size and knows how to allocate it on the stack. Yeah. Okay. All right. Okay. So you have rule, you have source, condition, action, and destination. Very, 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 very easy. Right. Okay. So let's do this. So we can start from here and build our way up. Okay. So let's make our core. So our core is the first thing is this rule structure, right? This rule structure. So let's start from here, this one. So we can define rule, go, you go. Okay, and you have type struct. I hope I didn't I didn't forget about the Go interface, about the Go syntax. Oh damn, it's too late in the day, and I guess I'm running a little late on juice, like low on juice. Anyway, we can do this. We can do this. So when should be a source? Source of event. So it's a source. If should be a condition, should be a string. So it's a string. And then should be then is an action, and two is a destination. Yeah. None of that is defined. So let's put some definitions. Right, okay. So you have the rule. Now let's go one step down. So the source, now we need different sources. So your source could be keyboard events, mouse events, events that happening in the system, whatever it is, like a connected USB or something, or Kafka message arrived, or SQS message could be consumed. So the source is not a specific structure, it's an interface. It's an interface. Let's hope this doesn't bite me in the ass in the end, because interfaces means when you pass something, it's gonna be boxed. So that's an allocation, I believe. Let's do that, and then we are going to have a some test that tells us if there is an allocation or not, if there is something that escapes the heap or not. And we're going to have another target for also for the linter and so on. So we are going to add step by step the checks that we want to do, and after we do any changes, we are going to run them and see that nothing fails. So we are going to put ourselves all the time under check. Yeah. So type. So here, okay, actually we can do something nice here. You can say type rule go allow you to do that. And here you can say, right, I can do that, yeah. Or is it like this? Yeah, it's like this. All right, so we have source, it's an interface, and action, an interface, yeah, very clever. Destination, yet another interface, not very creative. All right, yeah, so it's an empty interface for now. So now we need to know if you are, okay, so let's keep it that way. Let's keep it that way. And then let's have a directory. We are going to define sources, and another directory where it will have all the actions, another directory that will have all the destinations. So let's do this. So mcdir and sources, actions, destinations, sources, actions, destinations, yeah. And let's have like get keep in them. Touch sources, actions, destinations, dot get keep. It works, right? Yeah. Right. Okay, so you have the rule, you have the source, action, and destination, and you can define them. Damn, this like spam thing is horrible. How do I block people? So deleted it, yeah. All right, so you have source, action, and destination. So, okay, so now you can have a rule. So let's split this and in the readme. Okay, so now you have this structure. Now you need add rule and the start, right? Okay, so add rule, and you have context and the rule. Context and the rule, like any normal program. So you do that, and then function, and you start a context. Here you go. So you have your functions. So now you can maybe do this. All right, but of course you don't have this structure, like this source and this action and this destination. So we need a simple source and the action and destination. Okay. All right. So simple source. A simple source could be maybe time. So a ticker, maybe a ticker that ticks every x, whatever x is. and after it ticks, it emit an event. Oh, you also need input and output. You need data, like the event that gets emitted and an event that gets emitted and the side effect that gets applied to the system. I usually use calling them inputs and outputs, but also an output could be another input. So I'm not sure how I can, maybe they are the same type. Maybe I can consider it the same type. So you are maybe, your source is emitting events and your system is applying events, as in saving them or sending them to SQS or, yeah. So maybe it's all events. You are consuming and producing events. Right. Okay. Yeah. Consuming and producing events. That should simplify it. So let's have a directory called also events. Directory, so make var events. And touch events dot get key. All right. Okay. So now sources, we will define, okay, let's define that here first, you know, and then we are going to move it to another file. So type, and this is time struct. So source time. Yeah. And we need to know when, like how, the duration of every tick. So the thing is, if you have a source that you wanted to emit an event, which is the time, every period, you need to specify the period. So period time dot duration, right? Because we have this type in Go. All right, and this is a source. We still don't have anything. We're just trying to define some basic structures. So you have also the type, which is time event, and this will be the time of the event. So the time source is going to emit a time event every period. And an action would be, let's have pass or yield, which actually does nothing, does absolutely nothing. We still don't know what are, like, where the logic will be in this kind of structure, so bear with me. Okay, so now you have a source and an action, and we need a destination. So our destination could be the standard output. So pipe std out. This is a structure, and whenever you use this structure, whenever you use this destination, it's going to write the output events into standard output. So this is just an elaborate way to write the time every duration to standard output. Just a really elaborate way to do this simple thing, just as an illustration. That's all. Okay, so that means in CMD, you can, let's also delete this, we don't need it. CMD, firehose, main, and that means you can do this. You can have a var which is print time. This is a row, and every second there is no action. Then firehose yield, standard output, and that's it. Perfect. And ring time. So that's what we are trying to do. And then when you have a start, it should start. Right now it will do nothing. So, all right, shell. Can I do this? Ew, oh wow. Okay. No, that's awful. That's awful, bro. Bind warning line editing nothing. Okay, okay. Damn. So clear is not here. I'm doomed. No, thank you very much. No, 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 no. Let's do this here. Code, fire hose. Okay, so let's make a target. So instead of go run, instead of doing this, which works, let's make something that says make run, and it will run. So make file, and run is go run cmd fire hose, or the whole directory, you know, just runs all the go files in this directory. So if you do this, yeah, it's working. It's working as in it didn't give you any errors or anything. So that's good. So there are no compilation issues. That's the idea. But actually it does nothing. So Vaum, it does nothing. Why? Why? Okay, we didn't implement anything, so that makes absolute sense. So what we need is that when you start, you need to have a list of all the rules that were activated, that were added to the system. So you need to keep a list of rules somewhere, right? So you need to keep a list of rules, and this list of rules should be local to the context. You can't just have it a global array or a global variable. That doesn't make sense. So you really need to find a way to have the context be the scope of your rules. So you can create multiple contexts, and each context can have a different fire hose group of events. You can start all of them, you know, if you want. Also, this allows us to test in the future, because you can localize all of your stuff in this context, and when you destroy that, and you can create multiple instances at the same time. You can make them communicate with each other, so it makes it easier if you go with this approach. Okay, we now are going to have a problem. The first problem is that we don't have anything that can hold that value. So what we can do is we can add the value to the context. How we can do that? With context value. Yeah, so when you add a rule, like let's make it like quick and dirty now. I think this will escape the heap, but we are not here yet. So context with value and rule and context equal, yeah. So you are adding this, the context, and that, yeah. But if you add more rules, you can't just use the same key. So you need to find a way to attach all the rules to the context, and they have to have different keys, or you can have one key with like a map you can try to do that. So maybe we can like get or set kind of thing. So we okay, so let's try to do this like a type and rule ctx key, which is a string, right? Rule ctx key rule. There you go. And now you can do this. Rule key. Rules. Oops. Rules key. And this adds the rule to your context. Right. You're modifying the context, so you have to return it. So if you're modifying the context, you have to return it. So you can just return error, right? So you have to return the context and error. So you have to return this context and error. Oops. Context, because you modify it, right? So you modify it internally, you add a value to it or whatever. Yeah, so that means your interface can't be that. It has to look like this. You add a rule, get a context and the error. And if error, panic. Very good. Excuse me, what? Assign mismatch to variables, but returns 1. No, it doesn't return 1, and I saved here, didn't I? Can I restart the LSP? LSP restart. Oh, there are both of them. LSP restart workspace, LSP workspace restart. There you go. So yeah. How can I like GD go to definition? Yeah, it was GD. Okay, yeah, because I switched from Space Max to Dome Emacs. So it's a bit, my muscle memory is hurting me a little bit. All right. So when you add a rule, the first thing we determined is that you can't just modify the context and get away with it. All right. So with value, okay, so we need to get or set. So rules, value, rules, yeah. So if not okay, you have your role as like make rule 1, right? Like 1, and then context, yeah. Append 1 rule. Now, isn't that similar to just doing this? Same, right? Same. Yeah. Okay, so, and the context is you're adding the rules. That may hurt me, but yeah, let's see. And all right. No, okay, so it's get or set. So we get, if not okay, we are initializing it. If okay, we are going to append. And then we are going to set that in the context again. Yeah, it's gonna hurt a lot when when we try to fix the heap escaping the heap. It's gonna hurt. Let's see. Right, so you can add a role now, and at start, now let's get the rules. So let's get it. So the rules are coming from here. If okay, if not okay, return null. Otherwise, let's just print it like a slog and info. Yep. And the slog is like structured logs. Starting rule and then the row. So now if we run this, yes. So it's starting rule. The rule equals to when period 1 second. If nothing, then nothing, and two. It's just empty interface. The structure is really empty, so it doesn't print anything. We know that. We expected that. So it's everything according to the plan. Everything is according to the plan. Right. So now we can keep track of the rules, and we can keep track of the rules. I know I feel something is off because when you set the rule, okay, yeah, I need to see that. So when we say with value, does it always wrap the new value in a new context? Or does it know if there is a context already that has the value and kind of remove it or unwrap it or change it again? Let me see. So here, if parent is nil, create a context from nil parent. Okay, we can do that. If key is nil, we can't have the key now. Reflect light. Type of key comparable. Key is not comparable. Okay, so yeah, the key has to be comparable. Cool. And key is comparable. And then you create a value context with the parent and key val. And down there, the value context is the parent context, and the key value is any. So it always wrap it. You know what this means, right? So that means every time you add a rule, you're going to have a new context wrapping the old slice. So the old context has the old slice into a new context that has the new slice. So every rule actually is copying the slice and modifying it. That shouldn't happen. So we need to find a better way for this. I need to find a better way. Do we need to keep track of the rules? Do we need to keep track of the rules? Maybe not. Maybe not. Okay. Maybe we can do this. So instead of keep track of the rules, let's scratch all of that. Let's say we don't need to keep track of the rules, and that will make sense in a minute. Okay, let's not keep track of it. And the context is just returning context. No, it's not. Just returning an error. So we are back. We're back. And yeah, so with the context, and you add something, and that's really odd. Like, why this doesn't catch up? Why? What's going on? Really, do I have to restart it every time? That's dumb. Interesting. Okay. All right. Okay. Let's say you have a rule now. Okay. Let's remove this condition. We don't need it for now. So when you get a rule, you can get the source and you can subscribe to the source, or you can ask the source to start emitting events, or not yet, because when you are registering rules and you have a source and you need to start, you need to damn. Okay, so the problem is you can have multiple rules that are subscribing to the same source. So you shouldn't be creating the same source multiple times. You should be creating that source only once, right? So that means when you start your program and you're adding rules, you're not really letting the source starting yet. You have just to accumulate the rules and know what are the sources for each rule, and then you subscribe to this source so it can start to have events. So there is registration and then there is starting the sources. So we need to keep track of the sources and we need to keep track of the all right, okay. So how about the source? How about that the source could be something that emit an event, right? So the source is an interface of type T, and T is any. So far, T is any. But it emits a specific event, right? We need also type safety, so we need a specific event. So, also once you say source is T, you need to have it here, and you need to have it here as any. Right. And then the source need to have a way to start and stop, right? Start and stop. Yeah, kind of. Start and stop. So when you're stopping, you are telling the source, hey, stop emitting events, stop what you are doing. Yeah, okay, so you have a start. It takes a context, return a channel and error. Okay, start and stop. All right, okay, I'll buy it. So this means it's a channel that is only for read. So why we can't return a context? And when this context is cancelled, that means the source is done. Yeah. Well, the context cancellation is actually also a channel, right? So when a context is cancelled, it's actually writing to a channel, right? Yeah, I think so. So deadline, blah, 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 blah. Done is a channel. Yeah. So that means here we can just return context, right? And here we are stopping. All right. So now we can tell the source, hey, can you start, can you start to emit events? So when the source will emit the event, where is it going to emit it? So it's need to emit it somewhere. This is why it had the channel. No, bro, no, it can't be a channel, because you shouldn't be waiting on the events in a channel, because the channel is async. So if your source should wait for processing the event to do something, for this event, it can't be a channel, right? So you need to find a way for, no, it can't be a channel. So so if you have an HTTP request, for example, you get the request, you can just push it to a channel and wait. Maybe you'll get a response for this request. No. So it needs to be synchronous. It needs the callback. Needs a CB callback, which is a function that will take T and return an error. Yeah. So I guess that's what, yeah. So you can start, you can tell the source, hey, just use this function. Whenever an event comes in, call this function. And this function will return an error in case we couldn't process this event. So you can take whatever you want. You can do whatever you want with it. So this is what I'm imagining. So the engine will, this system will accumulate all the rules that are subscribing to a certain source. And then on start, it's going to group all of them per source. And for every source, it's going to activate only one function for the source. And when this function is called, it's going to fan out to every rule. So that means your rule has to be compressed into one function. So you can map this, fan out this function, this callback, into the list of functions, which each one of them is a rule. Yeah. So what you need is also to know if it's the same source or not. Enter the ID. The ID function will tell us if this source is the same or not across rules. So whenever a rule is using the same source, it will tell us if it's the same or not, because so for the time, for example, you can have two rules. Each one is each one is triggering every minute. But each rule will take time to process. One takes like milliseconds, and the other one is taking like a minute or so. So they shouldn't be waiting for each other, right? Because you are fanning out and you are waiting for all of them to be done in order to move to the next event. So you can't just say, okay, if the structure of the time is always, if the structure of the source is equal, then it's the same source. No, because that needs to be in control of the source itself. I think that needs to be in control of the source, right? Yeah, because sometimes there are attributes in the source where it doesn't matter really. So you set it or not, it's the same source. Yeah, something like if you are adding some kind of comments in the source, or I don't know, something to be logged or something, this shouldn't be forced as a new source. So the identity of the source should be in the hand of the source itself. The source should tell me its own identity. I shouldn't infer it from the data. I think that would be the right decision in this case. And we can do this in several other stuff, but we are talking about the sources now. So yeah, the source takes a type, and the type is used here. And now you have a rule of type T that uses source T. Okay. So, and here is going to be Firehouse time event. Firehouse time event is not generic. Now it's generic. God damn! I need to find a way for this issue. Okay, yeah. So it's telling us that time is not of like a structure of type Firehouse time. Okay. Can you just find that's like why? Oh yeah, because it doesn't implement the interface. Of course. So let's time ID. So it should be the period. T period string. And start. Okay. So start is a function that will emit a new time event and return a context. All right. So you have a ticker, and that ticker takes every period, and every time it ticks, it's going to do the callback. If there is an error, I don't know what to do with the error, to be honest. If there is an error processing the event, maybe we can log it. Yeah, error processing the event. And we need also to have the time, which is t. And so we are waiting either for a tick or for the context to be done. If the context is done, you stop the ticker and you need to cancel the context. So you need to cancel the context that you just returned. So yeah, this context, when it's done, so we need to have out context with cancel, yeah, and defer cancel. And so here we are returning. No, we shouldn't return in this case. No, we should cancel. Yeah, and return. So we loop endlessly. So we, okay, yeah, here we go. We only cancel in this case. All right, so let's see. So when you start the timer, it will take something to call back its event, to emit events, like an event emitter function, and it will return a context to tell you if it's done with its work or not, you know. So, and it will spawn a go routine, and this go routine will like spin infinitely, waiting for a new tick or for the context of the program to be done. And if it's done, you stop, cancel, return. Easy peasy. All right. So that means we need also to stop. Stop, yeah. And the stop with the so when you stop, you're giving, we need to give names to this kind of stuff. Need to give names. We can done and error, right? And this is done. Yeah. All right. So when we stop and we are getting the done, all we need to do but if we want to stop, why don't we just cancel the context that we passed? Because this context, if you cancel it, that means you want to cancel all the sources, but you don't want to cancel all the sources. You just want to cancel this source. So this source told you, okay, here is like a subscription, and you know, like, okay, I will call back this function, and if you want to cancel, here's a context. So, but why can't we, maybe there is a cleanup. Maybe if the source is trying to stop working, it needs to clean up. Yeah, okay. Even if it needs to clean up, it can use that, right? So this done here, it's also called done. Ticker cancel. Yeah, here. Done. Okay. But also we are not just waiting for the global context to be done. So if the global context is done, we are going to stop this context, stop the timer, and exit. And if there's somebody else that cancelled the context, done. Then stops, cancel, return. So in any of these things, we can do that, right? If I do this, it's going to be joined, right? I hope I'm right. Yeah. So if the program context, like in the general context, is done, or if the context we returned is cancelled, then we can just, you know, cancel what we are doing and clean up and go home. Right. Okay. Right. Oh, you see that? Now we can't just activate a rule. The rule is generic, so now you need to do this. See, it's getting complicated. It's getting complicated. And now, if you restart this, this should work. This doesn't work still. Can't use this. Yeah, okay, because we removed the stop and we didn't remove it from the definition. All right. Okay. So now you have a rule that is emitting a time event. It listens on the time source. Every second, the time will emit a time event and is going to call CB, the callback. Yeah. So start. So that means when you register or when you add a rule, yeah, we should keep track of the rules. should keep track of them. Yeah. So maybe we can wrap the rule in a way that we can inspect it. Do we? Do we need to wrap the rule in a way that we can inspect it? So, okay, so here you have the ID, you have the start. Now we know that the source is going to emit this. So when you add a rule, let's do the easy thing now. So the source start, you give it a function, and then you pass the rule to the condition. So rule, not the condition, sorry, to the action. Then, and the action should take context and it should take the event. Right. And then should be returning an error. We still didn't fan out or anything. So now we know there is a done here. Let's ignore it for now and return the error. Okay, so when you add the rule, it's going to start. So yeah. Okay, so when you add the rule, you need to keep track maybe of this context that is returned from the sources. So you can cancel it at any time. So rule, then, okay, now we have a problem. So the action is like an empty interface. Doesn't really have anything. Then what? What to do exactly? Then do, is it do? So process this event. So process this event. So the action should have something that says process this event with this context and return an error. No, but the action is like it's taking an event as an input and it's not doing side effects. It should return the side effect as another event. So it should return output out event, or so it should be another event, and another event is just any. Okay, now we are in weird territory. So we need this also to be something here, and it's going to return another type. So it takes a type and return, they don't have to be the same, right? So T and K maybe. Let's call them like in and out. So in and out. So the action is in and out, and here T is in and T is out. And the rule now has input and output. T redeclared and yeah, okay. Okay, so the so okay, in come on, in and out. All right. So now you have a rule that takes input and output. The source emit the input event, and the action takes the input, process it into an output, and then the destination, that's the missing one, but we are coming to it. We are coming to that. I'm not sure, should I name it IO or in and out? I think in and out is more meaningful. Yeah. So yeah, the action is taking a context and is processing an event, and it's returning an output. Yeah. So this says add a rule of in and out, and the rule here is in and out, and this is in, and this is out and error, right? Correct, yeah. And it's if error, no, that's all right. So we process and then we write to destination, right? So if error doesn't equal nil, you return error immediately. Otherwise, you need to write to the destination. So rule to dot send. Yeah, so maybe you send it, so it writes it to a database, write it to a queue, send the output. There's also an error here. Why not? Yeah, and now you have this send event, this send function. So send takes t of type any. Where is that? Oh, t. Okay, yeah. And t any. And now the destination is out here. So now you have your rule taking input and output, the source emitting input events, the action takes input, return output, and the destination takes the output and do something, whatever the fuck it's going to do with it. I don't care. Or I care. No, I care. Okay. All right. That's about it, I think. So when you start, you are telling the source, take this function. When you are going to emit an event, call this function. And this function is our runner. It is what it does, the stuff, the meat. So maybe we can extract it. But wait, let's see. Let's check first that it works, actually. Missing return. Oh, maybe we don't need this if condition. Just return directly. Return directly. We are going to evolve with that because we have to fan out and we have to wrap everything in different logic, and so this is just a start. Right. And actually the start is going to just ctx dot done. So it's never gonna return. You're just waiting on the context to be done. So that means we are going to get some errors here. Yep. Fire hose. So this is the input and the output, right? And then yield. Yield, of course, needs to implement the interface, right? It needs to implement the interface of this action. So yield, and this is yield is generic, so t of any takes anything, doesn't care, and is going to take that type and return it as it is. Just does not care about anything. Return the same event. So yield doesn't really do anything, right? So, and this is what we are trying to do. Yep. Pose fire pose dot time event. Damn. Okay, and standard output. And the standard output should take the event and write it. Should take the event and write it. Right. So same t of any, and it is going to send. Oh wow! All right. So it's going to write it to standard output. So it should be like really simple thing, like a font and println the event, right? Just print it. Println returns an error or anything? Yeah, it returns an error. This is interesting. Like printing to standard output could be an area. You could just close the standard output. Yeah, our standard output could be like a. It was initialized as a file on disk, and the disk is, you know, full, so it's going to fail. Yeah, makes sense. So generics, it's fun to work with, right? So yeah. So what I expect when I run now is that for every second the time is going to be printed. So let's try this. Here we go. But it's printing 1 second, 1 second, 1 second, 1 second. So something is off. You are calling time with T and T. Yeah, no. What? How did this even happen? Like time? Yeah, okay, yeah. The event is time.time. It's the time, the actual time. That means C is a now. Now. What? Undefined. Yeah. You want. Yep. That's what I want. So every second is doing that, right? Dun, 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 dun. What is M? Plus 1, 2, 3, and it's how is that? Like what's this? So you have the date, time, and the offset, and the time zone, and then M, as if it counts every second, right? From the start. Let me check. So this time, so it's I still have the muscle memory. Yeah, what's M here? So string is okay. List symbols. jump to, okay, like I need to jump to symbol. Jump to, my god, that really hurts. In Space Max, it was like, I really knew how to do it. Like space SJ, like search jump or something. Can evil jump to tag? Nope. So this, what kind of, really? Okay, now the string. Here you go. So what's M? Yeah, what are you? Who are you? Append M, and then the sign, which is plus or minus, and then it's appending M0, M1, M2. What are these? Where are they? M here, M here, ext. Okay. Yeah, oh yeah, okay. If the time has a monotonic clock reading, the returned string include a final field, M, which is the monotonic, where value is the monotonic clock reading formatted as decimal number of seconds. Okay, so it's the monotonic value. Yeah, so if your clock went backward, in some cases, like a second could be skipped or like counted twice. Sometimes in case also like of the DST, for example, like the day saving time, the time goes back 1 hour. Your time shouldn't go back 1 hour, so you get this monotone. Okay, now I learned something new. This is nice. This is great. Wow, I see 5 viewers here, but I don't see any comments. Everybody's silent today. Am I in the background? I guess I'm in the background. Yesterday it was more active than this. We talked a lot about AI and stuff. Sometimes it feels like the AI now comes up in every conversation. I don't know if this is good or bad, but I feel that we are all feeling the pain, kind of, when it's very impressive as a technology, but it feels like, okay, like now what am I doing exactly? What is it that the value that I'm adding? Judgment, maybe. Also responsibility. You take accountability for the work. So, all right, okay. So now we have the system working, right? We have the system working. We have a source, this source, and we are going, okay, let's leave it here for now, okay, because we may need to change it. There's something also that, I don't know, like, so something that annoys me here. First, let me just put that in Git, like stage it, just not to lose our progress. Something that annoys me with Go generic, that I have to specify that here. Like, for example, the destination doesn't care about the type. I know the rule needs a destination that can accept out, but and it will call without. But also the destination here, it can get any, so why not just, you know, accept any here, you know? So is there a way that I can do this, like any of the out? Isn't it possible? It is possible, right? Can't I do that? Can't I do this? Common. Yeah, I need to learn what is. By the way, is this too high? Right. Okay, so Golang generic. So what I'm trying to tilde. Yeah, I need to know the usage of tilde. What does tilde symbol means in this generic function? Yeah, what? What exactly does it mean? So I'm learning Golang currently generics. In this link, tilde, yeah, no, not that. Anyway, yeah, so it's accepting E and S, which is a slice of E. But this, I think, because it refers to a type here, means underlying type. It can read as S should be a type of comparable, or any other type which has an underlying type of comparable. Hmm. Okay. Yeah, okay. All right. That's fine by me. So that means we will be stuck to generics a little bit until we figure out a way to make this a little bit less verbose. Okay. So now we need so you have a rule, you have okay. Now let's extract them because they already look like a lot. So time, this is the time source. This is the time source. So sources time dot go package sources, and it is returning an event time event. We are going to get to that. So here this is going to be in the event time, and now we can actually use the same name, right? So it's time, and yield will be an action. All right. And what? All right. And std out is a destination. Perfect. And now we need to go to the source and change the name of the event. So now we don't need to use this, like time event can be called events.time, events.time, right? And you import events. Yeah, so your source is using the events because it emits events. And here events time, events time. Same events time, events time. So I'm using Copilot just to make it faster to complete the line. Not to write the whole thing. So you what? Cannot use firehose, blah 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 blah. Yeah, I know you don't see shit. Undeclared import name. Yeah. So this is in the sources time. This is in the actions yield and destinations standard out. And if I run again, it is working. Look at this beauty. Yep. Okay. So it is working, right? Now let's stage everything. Perfect. Okay. Yeah. So now you can create a role. You can have a source, an action, and destination. Like the basics. Now we need to look a little bit at, where is it? This role. We need to extract that. So check this out. So this start, and then start is going to pass in a function. This function. Let's extract it somewhere. Can I do this? Extract LSP extract. Wasn't there like, can I do this? And this is role to CB callback. Nope. Nope. It's not really supported. All right. Okay. Okay. So role to rollback. This is the role. And then you have a function which is role to rollback. And it takes a rule. Yeah, it takes the rule, but okay, so that's the thing. Like in, out, any, and here rule in, out. Yeah, it returns this. That turns a function, context, and in, and an error. So it returns a callback. right? I can define the callback as a like a type, but then when you are looking at the definition, you will see callback, and then you have to jump to callback to know the type. It's really annoying when this happens. Cannot use this value of type blah 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 as function in. Why? Why can't you? Hmm? So the callback, yeah, the callback should be getting context and input. So what's up? What's going on here? Let's compile and see. It will give us yeah, an argument. Cannot use rule to call back rule value of type function context in error as function in error. Okay. Yeah, I noticed that. That's a bit off. So when you are getting an event, you should also be getting a context, right? The callback should be getting a context to know when to stop. Because you can be getting HTTP request, that HTTP request has a context, and you should be able to cancel when the request is cancelled. So this context is the whole program. You're giving it to the source to tell it, hey, this is the whole your whole context, and if it's cancelled, stop everything. You know, like terminate what you're listening to. But every time you get an event, this event can have a context. So you can have a timeout on it, for example. So, and that means actually, that means our source time. There's something weird with Doom Emacs. It doesn't refresh the files. It doesn't like, as if it's stupid. What's going on? Like, here, I'm trying to find a file. Why it can't find the new files? Maybe because they are not committed? Is it? Is that the problem? Anyway, sources, time, and this should be context, right? Now it's two types. And when it's calling here, it should give you a context only for this. But we can, nothing stops us from using the program context like that, the context of the whole thing. Because this is not an HTTP server or a gRPC where you have a context for every request. So we can do this now. I think now everything will compile, right? Yeah. Yay! Yay, 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 yay. We are printing time every second. That's a lot of code to print time every second, but we are making a pattern here. We are making a structure. This is just an example. This thing is not to print the time every second. It is now to print time every second. Damn. Rule to call back is getting a role, and it is returning a function, a callback function. Mhm. Yeah, and the callback function is calling the process with the event and calling the send with the output. Okay. Okay. This sounds nice. All right. Great. Okay. We have been streaming for what? 2 hours now? 2 hours. That really passed by really fast. Really fast. Okay, now we have something that is running. And we have a main. So now let's take this as an example and add it to the README. Nice. So now we can say working example of source, action, destination. We still didn't have the condition. Destination, wiring. Yep, wiring. Everything as expected. Okay, I think we are done for now. We've been streaming for 2 hours now. It's a bit much for me after a long day of work. But I promise tomorrow to continue what we are doing. We will try to fan out what we have done so far. So whenever you can have one source of time and multiple rules that are fired based on the time without initializing the source multiple times. So the source doesn't have to work hard, just emits one event and just waits for it to be processed. Then the engine will be the one responsible for processing all of the rules. So, yeah. All right. And also we need to get away now to have a start and not just when you register the rule start to work. It's like when you start the engine. When you start the fire hose. Who chose this name? It's a really bad name. Who chose that? Anyway, okay, I think we are done for now. And thank you very much for listening. And maybe we will meet tomorrow. Right. See you.